Ladies and gentlemen, so today what we're going to be doing is we're going to be talking about Lewis dot structures yet again. And we're going to talk about reactivity a little bit, okay? Just like we were doing with the ions from last week. So we're just going to refresh a little bit, and then I'm going to let you guys work on some on your own. And then if you have questions, you can always email me, send me Canvas messages, or if you guys look at the answer key that's also posted on Canvas, you should be able to find everything you might need. So if we take a look, the first question says how many electrons are needed to fill the outermost shell in most elements, okay? So remember that keyword most here, okay? So almost all of them, okay? Except for those couple in the first row, almost all of our other elements want how many valence electrons, all right? Remember, these are valence electrons, right? So remember, it is going to be, in fact, 8 electrons, or 8 valence electrons is what's needed or what's wanted to get to our full valence shell. All right. And then how many of them can fit in that first orbital or that first shell? Okay, so that's the first ring outside the nucleus. If we remember, after that first ring outside the nucleus, you can get up to 2 valence electrons. Because remember, on our periodic table, we look at my rough little sketch of the periodic table. In our first row, we got hydrogen over here, and then we go across to helium over here. We just have those 2 elements in our first row, which means we can only have 2 electrons in the first orbital, or in that first shell, that first ring. All right. So now that we remember that, okay, now we can talk about the actual Lewis dot structure for, let's start with hydrogen. Okay, so hydrogen is the element symbol. So remember, there's two parts. We need the element symbol, and we need the valence electrons. Okay, so if you remember, the element symbol for hydrogen is, because it's the first element, it's H. And because the first element only has 1 electron, and that 1 electron is its valence electron, or its outermost electron. So we're just going to put 1 dot right above that hydrogen and call it a day. Now, hydrogen only has 1 ring. How many more valence electrons would hydrogen need to gain its to fill its outermost ring? So its only ring. So if you remember, hydrogen wants 2 electrons, or valence electrons. And if it already has 1, we take our 2 minus 1. 2 minus 1 is in fact just that 1. So it just needs to get 1 more. So if you remember, hydrogen again started with 1. And if it gained 1 more right here, it would have its 2, it would have its full ring, it would be happy. But remember, if it gains that 1 extra electron, it's gaining a negative charge. So it's going to have a -1 charge here because it gained an electron, right? So it gained an electron, it gets a -1 charge. And then if we look back here, it says that hydrogen only has 1 ring. How many valence electrons would hydrogen need to lose to empty its outermost ring? And so if we add hydrogen wants 0 now. And so if we want 0, 1 minus 1 gives us that 0. So hydrogen, just like before, could lose that 1 electron and be happy with a +1 charge. So it would look like hydrogen with a +1 charge would be our final answer here. And both of them could be correct. All right, it says which would be easier for hydrogen to do to become stable, by losing or gaining electrons? Or is it just as easy to do both? It is, in fact, just as easy for hydrogen to do both. Remember, hydrogen's fine with going either way. It just depends on if if it's with an element that wants to take its electron, or if it's an element that wants to give its electron. So hydrogen will do both. All right. And now let's go ahead and do one more together just to kind of go through what's happening. Okay, so if we look at beryllium, beryllium is the element Be on the periodic table. And so if we're looking at beryllium, beryllium is going to have two valence electrons because it's in our second column on the periodic table. So we'll put the first one up here and our second one right here. Right? So how many valence electrons would beryllium need to lose in order to have an empty shell or to be stable again? So beryllium wants 0. And if it has 2, to get to 0, we have to take away 2 more to get to 0. So we go from beryllium with its 2 valence electrons, and those both go away to become beryllium with a positive 2 charge because it lost 2 negative charges. So that is one option. The other option is beryllium wants 8, wants to gain all its valence electrons to have a full outer shell. So if it wants 8 and it started with 2, we need 6 more. So again, we start with beryllium right here. We start with its 2, and we can give it 1, 2, 3, 4, 5, 6, and that would become a -6 charge because we gained 6 negative charges. So which one was easier for beryllium to do? Going to a +2 or going to a -6? Because 2 is less than 6, and finding 2 places to put 2 electrons is easier than finding 6 places to take 6 electrons from. Beryllium would rather lose electrons than gain electrons. It's easier for beryllium to lose those 2 than to try and find 6 more to take from other places. So you're going to do that for the last few questions, 5, 6, 7, 8. So you're going to go through the same thing that we just went through for questions 1, 2, 3, and 4. You're going to answer the rest of them. If you have any questions, again, you can email me or check the answer key that's posted under today's assignment as well. Have a good rest of your day and hopefully see you soon.